Okay, so this is out of the homework from 10.3. This is number 34, except I'm adding a hint to the instructions. So the instructions are to solve this homogeneous, linear, fourth order differential equation subject to these initial conditions. And yeah, like I said, I put in this hint. This hint is probably, a bit mysterious. Like, why am I telling you the partial fraction decomposition of this very particular thing? It's because this exact thing is supposed to come up when we solve this. All I'm doing is I'm giving you a way to get through this problem without doing the partial fractions yourself. Part of this is just out of understanding that these problems are a bit time consuming if you have to do every single step. Also, this kind of gives you, like the fact that I'm telling you this in particular, this kind of gives you a way to check your work. If you don't find this information useful, that's probably because you did something wrong. Or because I did something wrong, but I'm trying to be careful. So, let's do the Laplace transform of both sides. How does this go? The easy part to remember is s to the fourth x. But then I start subtracting, there's going to be a minus, it's going to be s cubed times something. It would be s cubed times 0, so I won't even write that. And then the next power of s down would be s squared times 2, so 2s squared. Then there would be a s times 0, and then my next power of s down would be just s to the 0, which is 1, times negative 13. I'm subtracting all of these, so I will write plus 13. Right? So this is just the Laplace transform of x, the fourth derivative of x, plus 13 times the Laplace transform of x double prime, which would be s squared x, minus s times this, so that's 0, minus 1 times this. So I'm there, plus 36x equals 0. So there I am. I took the Laplace transform of both sides. So let me collect all of my x parts, because what am I trying to do here? I'm trying to solve it for x. So s to the fourth, I would have a 13s squared and a 36. And now, as I've pointed out many times, this is just the characteristic polynomial of this equation. That basically always happens. But what's the rest? I've got actually, I'll get the rest to the other side. So on the other side, I'm going to have a 2s squared. And then I've got some constants. Let's see, I've got a 13 minus 26 here. So this is like a negative 13 on the left. So when I move it to the right, it would be a positive 13. Okay. So x is 2s squared plus 13 over s squared plus 4, s squared plus 9. And now we're at the step where all I need to do is I need to find the inverse Laplace transform of this. And what do? We do the partial fraction decomposition. That's exactly why I told you the partial fraction decomposition of this thing. If I was doing this problem and I got to this point and it was some other fraction, like maybe the numerator was a little different or the denominator was a little different, I would know I did something wrong. Oh, and I forgot to mention something. Yeah, obviously I factored, yeah, obviously I was getting a little bit ahead of myself here. I factored the bottom, but this isn't too hard to see. This is just thinking of two numbers that multiply out to 36 and that add up to 13. That's how you can factor something like this. But right, this is the fact that this is what you get is precisely why I gave this hint. So if you got something slightly different than what's in the hint, then either I made a mistake, which I'm going to try to be really careful not to, or more likely you made a little mistake. Anyway, this is what we get. And now this is relatively easy. There's no translation because it's not like I have s plus 2 parentheses squared or something like that. So there's no translation. These are things that I should basically just be able to look up in the chart. Okay. These look like signs because I don't have an S on the top. So this one would look like sine of 2t, except I don't have my 2 on top. I just have a 1 on top. So this should be 1/2 sine of 2t. This one, if I had a 3 on top, this would be sine of 3t, but I don't, so it's 1/3 sine of 3t. So that's it. We're good.